Bismillah. Let's begin with section 15.8, spherical coordinate system and triple integrals. We have a new method to represent points in space. We have new coordinate system, which makes our life easier with special surfaces and bodies in space, especially for the solids and surfaces symmetric about the origin. Like, for example, cones and spheres, its representation in this coordinate system will be easier. Instead of square roots, complicated square roots and stuff, it will be easy. For example, rho equals 5, like this. Rho equals 5, this is simple equation. This is a sphere. Instead of writing x squared plus y squared plus z squared equals 25, instead of all of this, this will be the representation in spherical coordinate system. Instead of z equals root x squared plus y squared, which is the upper half cone, it will be phi equals, phi is an angle, a new angle, is pi over 4, like this. Very simple equation. What is this coordinate system? It is in this representation. Any point in space, let's have this x and y and z as usual. Any point P of coordinates, x and y and z as usual. This is the rectangular coordinates. It has another representation, rho. What is rho? Rho, it's the distance from the point to the origin. Are you with me, Shihab? So it's rho. The distance from, so rho is OP, the distance from the origin to the point. And what is theta? Theta is the same theta in polar coordinates and cylindrical coordinates. What was that? Remember, we make the projection of P into the XY plane. This is the projection of the P into XY plane, and the angle between, this is the angle. This is the angle theta we are used to. Theta is this angle. It is the same theta in polar coordinates and cylindrical coordinates. The angle between the x-axis and the projection of OP to the XY plane. So this is P prime. So the angle between OP prime, not OP itself, OP prime. P prime is the projection of P on XY plane, and the OX axis. So theta can vary from 0 up to 2 pi. You can make whole cycle with theta. The new angle is phi. This is the angle phi, which is here, is the angle between the z-axis and the vector OP. So it is the angle. This is the new angle here, Shahab. The angle between OP and z-axis. OZ axis. Notice that this can be in any direction, and phi is between 0 and pi. Phi varies from 0 to pi. This is very important. And theta between 0 and 2 pi. So again, we have new representation for any point in space using the distance from the point to the origin, which we call rho, rho, the Greek letter rho, and the angles and the other two angles, the angle between OP and the z-axis, which is called phi or phi, and the angle theta between the OX axis and the projection OP prime, projection of OP to the XY plane. This is the usual theta we are used to in polar coordinates and in cylindrical coordinates. What is the relations? What are the relations between the new coordinate system, rho, theta, and phi, and x, y, and z? And what else? We have another representation. This is spherical. We have also r, theta, and z in cylindrical coordinates. Theta is the same as theta. Theta is the same theta. What is the relation between r and rho and the other coordinates? This is very clear here from this triangle. This is the projection, so this is a right angle. So we projected P onto the XY plane, so this is a right angle. So we have a right angle triangle P, P prime O. And this angle phi will be equal to this angle phi. They are alternating angles. And therefore, this is rho. Sorry. This is not rho, this is r, as usual. R, the distance from O to P prime, which is related to x and y with the usual relations from polar and cylindrical coordinates. X equals r cosine theta and y equals r sine theta. We will write this soon. And this is z. Here is z, p, p prime. Z is the vertical distance from P to the XY plane, P, P prime, which is Z. Z equals rho cosine phi, because Z is adjacent to phi. So Z equals rho cosine phi, and R equals rho sine phi. And the rest is easy. This is the whole new idea, the whole new transformation. R is rho sine phi, because R is opposite to the angle phi. And Z is adjacent to the angle phi in this right angle triangle. That's it. So we have this triangle. I'll draw it here in the usual form. This is the hypotenuse rho, and here we have R, and here the angle phi. And here we have Z. So the relation is, the first relation is Z equals rho cosine phi. The second relation is R equals rho sine phi. What is rho again? Rho is the distance from the point P to the origin. The rest is easy. We have these new two relations between R and Z and rho and phi, the new angle made with the Z axis. So Z equals rho cosine phi, as you see. Z equals rho cosine phi. R equals rho sine phi. From R equals rho sine phi, we can continue our calculations to find the x and y. What we'll get, we know that x equals r cosine theta. Where is theta again? Theta is here in the xy plane, between the OX axis and the vector OP prime. OP prime is the projection of OP on the XY plane. So x equals r cosine theta, so it is rho sine phi cosine theta. Again, R is rho sine phi. So we replace R with rho sine phi. and then multiply by this cosine theta. Why? R cosine theta is known from polar and cylindrical coordinates. And y is R sine theta, which is again the same story, rho sine phi sine theta. So if we know rho, if we know the spherical coordinates, rho, theta, and phi, we can find the rectangular coordinates x, y, and z. What is x? It's rho sine phi cosine theta, and what is y is rho sine phi sine theta. Can make it in 2 steps to make it easy. So again, this is z. Z is the easiest one because it is in the same triangle with rho and r. Z is the side adjacent to phi. So it's rho cosine phi. Rho is the hypotenuse. So again, z is rho cosine phi, x is rho sine phi cosine theta, y is rho sine phi sine theta. This is what is used to be r. This is what is used to be r. R cosine theta and r sine theta, as we are used to, or we are familiar with this from polar coordinates and cylindrical coordinates. So we can write rho square equals x square plus y square plus z square, because you see from this triangle, rho square equals r square plus z square. It's right angle triangle. Can write it here. Rho square equals r square plus z square, Pythagoras theorem. And r square we know is x square plus y square. So the relation between the distance r rho and the 3 rectangular coordinates x, y, and z is the Pythagorean theorem in 3D, or the length of the vector, the norm of the vector, the magnitude of the vector, same formula. So we can write rho square equals r square plus z square. Tan theta, as usual, is y over x. Cosine phi from this triangle is z over rho. Tan phi is r over z. All of these are clear from this triangle. So let's begin our first example, given some spherical coordinates to change it into rectangular coordinates. Transform this from spherical to rectangular coordinates. What's spherical is rho, theta, and phi. What is rectangular is x, y, and z. How to transform from rho, theta, and phi, the spherical coordinates, into rectangular x, y, and z? We have these relations. We can remind ourselves with these relations easily. As usual, we have from polar and cylindrical, x equals r cosine theta, y equals r sine theta, and then substitute for this r by rho sine phi. This is rho sine phi. That's it. Therefore, we get rho is, this is rho, this is theta, pi over 2, this is phi, 3 pi over 4. So the rest is direct substitution. So rho is 2, sine phi is 3 pi over 4, cosine pi over 2. Cosine pi over 2 is 0. This is the x coordinates. The y coordinate will be rho again, same, sine 3 pi over 4, sine pi over 2. Sine pi over 2 is 1. Sine 3 pi over 4 is the same as sine pi over 4. Supplementary angle, which is 1 over root 2 times 2 will get root 2. The easiest coordinate here in this transformation from spherical into rectangular is the z coordinate, which is rho cosine phi. Why is that? Z equals, you see Z is the side adjacent to phi, so it's rho cosine phi. Rho cosine phi, so we get rho is 2, cosine phi is 3 pi over 4, which is negative cosine 2 times negative cosine pi over 4. Sine 3 pi over 4 is the same as sine pi over 4, but cosine 3 pi over 4 is negative cosine pi over 4 because it is in quadrant 2. So it's negative root 2. Therefore, we get the coordinates in a rectangular system. So P, which was given 2 pi over 2, 3 pi over 4 in spherical coordinate system is the same as what? 0, root 2, negative root 2 in rectangular coordinate system. Rectangular x, y, z. Spherical rho, theta, and phi. Another example, direct transformation, change from rectangular to spherical, the other way. So we are given x, y, and z, and it is required to find what? The spherical coordinate system. We need to find the rho, theta, and phi of this point. This is x, y, and z. This is x, because this is rectangular. This is x, this is y, this is z, as usual. How to find rho? Rho is known by Pythagorean theorem in 3D. Rho square is, or the magnitude of the vector, rho square equals x square plus y square plus z square, which is 3 plus 9 plus 4. So we get 16. Therefore, rho is square root radical of 16, which is 4. This is rho. What is theta? Theta, you know theta. Tan theta is y over x from polar coordinates. You don't have to remind yourself with this. This is the x, this is the y, this is the r, this is the theta. Tan theta is y over x. As usual. So we have negative 3 over negative root 3, which is root 3. So we have the y is negative and the x is negative. So we are in quadrant 3. We are in quadrant 3. So the angle is pi plus this pi over 3. The angle whose tangent is root 3 is pi over 3, the acute angle. But we have to add pi because we have x negative and y negative, so our angle is in the third quadrant. So theta is 4 pi over 3. What is the third coordinate in spherical coordinates? The phi. How to find phi? We know the relation. Phi is related to the z. We used this relation before. Z equals rho cosine phi. So cosine phi equals z over rho. We have z given negative 2. And rho is calculated to be, so let's do it slowly. Z is negative 2 and rho is 4. So it is negative half. cosine phi is negative half, so phi is, if cosine phi is half, so phi is 60 degrees or pi over 3. This is the acute angle, but we need its supplementary angle. So phi is supplement of pi over 3. What is that? It's pi minus pi over 3. It's 2 pi over 3. So we get P equals, this is in spherical. We are given a point in P in Cartesian or rectangular coordinate system, and we need to find its spherical coordinates. So this transformations is easy. How to go from the Cartesian to rectangular to spherical, or spherical to rectangular, or even to cylindrical, all of this is easy. The question is why we need these spherical coordinates? Because I mentioned before, because some equations are easier in spherical coordinates. I mentioned here, you see, this equation rho equals 5, the equation of a sphere whose center is the origin and its radius is 5. So very nice equation, very simple equation, instead of all of these terms. And as you know, when we go from z, the smallest z, to the biggest z here, we have to go from the negative square root 25 minus x squared minus y squared up to the positive square root of the same story. Very long story, complicated radicals. Here, it's rho equals 5. The whole body is from rho equals 0, from the origin into the surface of the sphere, from 0 to 5. So it's easier equation. The equation of the cone, z equals root x squared plus y squared. This cone, we drew it before, we sketched it before. Its equation in spherical coordinates is very easy. Phi equals pi over 4. Because it is all the points having this angle phi equals pi over 4 in all directions. So it is a cone. We will derive it again. So we will need these transformations, and we need this coordinate system to make our life easy, to have nicer equations of these symmetric shapes of spheres and cones and all of this stuff. So we have some question of this type. Sketch the graph of rho equals 3. So what is rho equals 3? Rho equals 3 is a sphere of radius 3 and the origin as the center. Sphere of radius 3 and origin O is its center. How to come from this equation into this equation? Square it. So it's rho square equals 3, and rho square, as you know, is x squared plus y squared plus z squared. So this is the usual standard equation of a sphere whose center is the origin. Now we can, if we need to scan all of this region in space, the whole points inside this sphere, we can write what? Rho varies from 0 to 3. And this is exactly what we will do. And this is exactly what we will need to do triple integrals using spherical coordinates. So we have this nice equation for the sphere and nice inequality for the solid inside, or the region inside the sphere. Graph, the second graph is theta equals pi over 4. Theta, be careful here because we have two angles. Theta is the angle between the x-axis and the projection of the point. This is the x-axis. And phi is the angle between the direction, the vector of the point, the position vector of the point with the z-axis. So we need to distinguish between them very carefully. So what is the situation here? The equation is theta equals pi over 4. Theta equals pi over 4 means all the points having this angle. The points having this angle, with the x-axis, whose projection have the same angle with x-axis. So for every phi, for every z, for every point having this angle, this angle with its projection, this is the locus of these points. So what we will get? We will get half of this plane. All of these points here, this projection, we will make the same angle. Here, we will make the same angle. وهكذا, and so on. All of these points on this half plane will make an angle theta equals pi over 4. If it is equals, if theta is pi over 2, we will get the zy plane. If theta is 0, theta is 0, so we get xz plane or xz half plane. Theta equals pi over 2, we'll get zy plane, half plane. Why I don't say a plane? I correct it with half plane because the other side of the plane, the other half of the plane, we will have another angle. Theta will be pi plus pi over 4. It's 5 pi over 4. Okay. Another example, phi. Now phi equals pi over 4. Phi equals pi over 4. What we have here? No theta, so it's independent of theta. Theta is free to be any angle. No rho, so rho is any distant, is any point with any distance. The only condition here is to have this angle. The point P, whose position vector OP making an angle pi over 4 with the z-axis. The phi is the angle of the position vector OP with the z-axis. So whenever okay, go on Shahab.
Oh, what's the difference between B and C? يعني هما الاثنين pi over 4 صح؟
P and what?
اللي هو الريكتانجل والابسايد داون كونز.
This one, the angle here is theta. The angle here was theta, not phi.
Okay, تمام.
So here rho was anything, phi was anything. But theta is pi over 4.
Okay.
So when theta is a constant, we get a half plane. When phi is a constant, we get a cone. Half a cone, exactly. Because this P can move around circularly in a circular motion with having the same angle with this z-axis.
ثانية يا دكتور, when phi is A تبقى half cone?
Phi is constant.
تمام ماشي, thank you. يبقى half cone مش full cone.
Yes, half cone. The other half cone, the other half will have this bigger angle. Look at this phi. Phi equals 3 pi over 4. We will get this bigger, the other side of the cone, the other half of the cone. Like here. If you need to have the other part of the plane, the other half of the plane, this one, you need to go for theta to add another pi for theta. Theta equals pi over 4 plus pi. To go for the other half of the plane, this side. Look at the, okay, a question here. If we need to write the equation of this cone in x, y, z coordinates, rectangular coordinates, Cartesian coordinates as usual. So what we have here? So it's phi equals pi over 4. What is this? Means tan phi equals 1. Tangent of pi over 4, which is 1. What is tan phi? Let's go back to the original triangle. Here, what's tan phi? Do you see it?
Tan
What?
phi.
Yes.
Adjacent.
Opposite.
Z
Opposite.
over R.
Opposite over adjacent. So it's R over Z.
Z.
Let's go to the original. Yes. R over Z. Yes. Go to the original triangle. Yes. This is the opposite. And this is the adjacent. So it's R over Z. What we will get here?
R over Z.
Yes. Equals 1. Therefore, Z equals R. And what is R? X squared plus Y squared under the radical. Look at the equation of the cone, the half cone. So we are usually given this sort of equation, and we transform it into spherical or cylindrical as required to solve it, to make the solution easier, because the space or the region in space will be easier represented by this way. Look at this, which is phi equals pi over 4. Look here, Z equals square root of x squared. This is the same, but this is in spherical coordinate system. This is rectangular or Cartesian coordinate system. Got it?
Yes, Dr.
Okay. Another equation, which is very important as well, because we studied it before in cylindrical. You know this, rho equals 2 cosine phi, but there it was r equals 2 cosine phi. Now rho equals 2 cosine phi. The question is to sketch the graph of this equation. The idea is, what is this? If we are, if it was r equals 2 cosine theta, it was a circle. I write it. We studied it before. I'll review it with you. In polar. In polar coordinate system, r theta related to xy in 2D. In 2D, if we have r equals 2 cosine theta, what this represents? What this equation? What does this equation represent? We can remind us. The idea was to change it into xy. It was easy. How to do that? Multiply by r to get r squared equals 2r cosine theta. Why is that? Because we know r cosine theta and we know r squared in terms of x and y. What is r squared? Shahab?
R squared هتبقى
Yes.
x squared plus y squared.
Yes. What is r cosine theta? It was x.
Okay.
Yes. So this, what is this equation? You know it now. You know it by now. This is an equation of a circle. How to put it in the center radius form so we can complete the square. X minus 1. Can do it slowly if you need to. If you need to. X squared minus 2x plus y squared equals 0. We add 1 here and we add 1 here to complete the square to get x minus 1 all squared plus y squared equals 1. Yes, circle, center is what?
1.
1, 0. Radius is 1. So it is a circle. If we, It's very important to know this. To keep this in mind, r equals 2 cosine theta is a circle, but not with the center at the origin. It is shifted center to 1, 0 or 0, 1 if it is sine and this sort of stuff. The idea is how to get the center by this way. Multiply it by r first and complete the square. This is one way. Got it يا جماعة؟ افتكرتوا؟
هو
This is-
دكتور هو الار كوزين ثيتا بقت اكس ازاي بالظبط عشان
polar coordinates. Polar coordinates. Okay.
اوكي بولر اوكي يس
Yes. In polar coordinates, x is r cosine theta, y is r sine theta.
ساين
This is the idea. So when we multiplied, we get r cosine theta, which is x. If it was sine, we get r sine theta, which is y. R square in all cases is x square plus y square. So this is very important equation in polar coordinates, which is a circle with shifted center. I'll draw with you here. We have a center 1, 0. 1, 0 is here. So, and radius 1. So this is the circle. It's a circle with radius 1, but with center 1, 0. Center is not at the origin. This is very important. It can be r equals 2 sine theta. You get the circle on the y-axis. So we have studied this many times in polar coordinates and cylindrical as well. So let's have the general form now. Rho equals 2 cosine phi. We have the new symbols for today for the spherical coordinates. This is spherical equation. Spherical coordinate system. Rho, theta, phi. How to change it into x, y, and z? What is this? The same situation, but this is in 3D. In polar, this was a circle. In spherical coordinate system, this will be a sphere. How to do it? The same way. Multiply by rho to get rho square. Multiply by rho here to get rho cosine phi. Rho cosine phi is z. Rho cosine phi is z. Is it okay with you?
Yes.
Yes. Yes.
أيوة.
Z equals rho cosine phi. So rho cosine phi will be changed with z, and rho square is x square plus z square plus y. This is again an equation of a sphere. This is a sphere, but the center is not the origin because we don't have here the radius. We have a variable. So how to get rid of this z and get the radius? We have to complete the square. The same idea. Complete the square. Plus 1, plus 1. Plus 1 here to the left, plus 1 to the right. Move this to z here. You get z square minus 2z. Add 1 and add 1 to the right. You get this 4. So it's a sphere. Exactly a sphere. But what is the center? What is the center here? Yes.
Center
0,
is 1.
0, 0, 1. X 0 is subtracted from x, 0 is subtracted from y, 1 is subtracted from z. So the center is
0,
0,
0, 1.
0, 1. Yes. The radius is, the square root of this is 1. So what is this sphere? This sphere will be, as you see, this is x, y, z, and this is the origin. This is the center. Center 0, 0, 1. This is the z-axis. So the sphere here is shifted up along the z-axis to have this, the center moved 1 unit up. What is the equation in spherical? Look at this equation. Rho equals 2 cosine phi. Look, this is the equation. So all of these points on this sphere have this equation. Rho equals what? 2 cosine phi. So when we need to scan this region, we go from the smallest row here. So rho varies from 0 to scan all of the points inside this sphere. Rho begins with the smallest row at the origin 0 up to the points on the surface of this sphere, which is given by this equation, 2 cosine phi. These are the limits for these points on the sphere and inside the sphere. Any question? So move phi, wherever theta and phi are, rho can scan them when you scan rho from the inside to outside, and move the theta from 0 to 2 pi, and phi from 0 to pi, you get all the points. Or in fact, here phi is from 0. Here phi, this is very important remark. Here phi is 0. Phi begins at the z-axis. And move phi to the last point here, which is here phi is pi over 2. You don't go to phi equals pi here, because no points under the xy plane. So these are the bounds of the points inside this domain, this sphere. Okay. I leave the rest of these transformations. This is easy. You can do it yourself to change from spherical to cylindrical, from cylindrical to spherical. This is easy. So let's go for the sketching the regions described by given inequalities in the spherical coordinate system. Example, sketch the solid described. Look carefully, we are given a solid. Why solid? Because we are in triple integrals now. Sketch the solid described by the inequalities phi between 0 and pi over 3. Rho less than or equal to 2. Who can help? Phi equals 0, phi equal to pi over 3. Who can remind me? Studied this. Phi equals 0 is what? Phi equals pi over 3 is what?
Oh, phi equals pi over 3 equals root 3. Well,
no, this is phi, not tan phi. Phi. So we had this in the introduction in the previous examples. Okay, let's go back to phi equals constant. Phi equals constant gives you what? The example to the left here. Phi equals pi over 4 gives you the half cone up, the upside down cone. This is the cone phi equals pi over 4. All the points having this angle with the z-axis. So it's a half cone with half vertex angle pi over 4. We mentioned what? What else? If theta is pi over 4, so it's a half plane. If theta is constant, it's half plane. If phi is constant, it's half cone. If rho is constant, we get a sphere with center 0. So again, phi equals 0.
Phi is constant.
Phi is 0 is the z-axis. Phi is pi over 3 is, yes, phi is constant here. Phi, this bound. Phi is pi over 3 gives you what?
The upper cone.
Yes, half cone. Yes, half cone this way. This is the z-axis. This is phi equals pi over 3. This is the upper half cone. From phi equals 0 here, phi equals 0 from the z-axis. So this inequality gives all the points inside the half cone phi equals pi over 3. The second inequality. So we get all points inside this half cone. And here, rho less than 2. All points what?
هو row less than 2 ممكن هنكتبها بقى في equation x squared plus y squared plus z squared.
If you need to, if it is clear for you, we say it directly. All points inside what? A sphere with center O, radius 2. Rho equals 2. Center origin, radius 2. If you need to write the equation in x, y, and z, write it. But if this is clear for you, go for it directly. So we have here this to draw. So we need to satisfy these two inequalities together, Shahab. We need the points inside this cone. We need the points, all of the points inside this cone and inside this sphere in the same time. In the same time. So we sketch this half cone, upper half cone with semi-vertex angle pi over 3. We need the points inside this cone. And inside what? But notice that this cone is infinite. This cone is extended here. So we write like this. It's extended up there, but we don't go for infinity because we are restricted to be inside this sphere. We need rho to be less than or equal to 2. So where are the points we are looking for, Shahab?
On rho equals smaller than or equals 2.
Yes, inside the sphere. So I drew this sphere or part of it. I don't need all of this. I need the points inside the cone, the half cone, and inside the sphere in the same time. Where are these points?
On the surface بتاع الsphere.
Yes.
اللي هو اللي هتبقى اللي هي الفاي اللي هي 2 صح؟
Who can tell? Who can tell? Katrina, Sama, Shihab.
مش هناخد
Where are the points, Katrina? Satisfying these two conditions together.
اللي هي عند السيركل صح؟ هي السيركل الفوقانية اللي هي بتميت الاثنين صح؟ هو ده اللي حضرتك عايزه؟
Yes. This is rho equals 2 here. We need the points inside the sphere and inside the cone. Where are these points, Sama?
All the points are inside the cone?
Inside the cone, or inside the sphere. These are the points. These are like this ice cream cone with this topping without the rest of the sphere. Have you seen it? Now we took all of the points inside. These points satisfies both criteria. Their phi is less than or equal to pi over 3 means they are inside the cone. And the rho is less than 2, so they are inside the sphere. Why? For example, this point is not taken. Why? which it has a rho less than or equal to 2. It is inside the sphere, but not inside the cone. Got it? This point, it's inside the cone because phi is less than or equal to pi over 3, but r bigger than 2. Here, r less than 2, but phi is bigger than pi over 3. So this is the required region. This is the required region, Katrina. Got it? Have you seen it, Sama?
Oh, yes, sir.
Okay. We need what, ya Shahab? Shahab, we are asked to find the region whose points satisfy these two inequalities, two conditions. Their angle phi is less than pi over 3, means the points inside the cone. And in the same time, and this end is very important, rho less than or equal to 2, and they are inside the sphere as well. So the points inside the sphere and the cone give this region of intersection of the cone and the sphere, which is shaded or dotted green. So how to write it? E equals all points rho, theta, phi, satisfying phi less than pi over what? 4? Pi over 3. And r less than or equal to 0, less than or equal to 2, sorry. And this 0 is not important. This is not important. Of course, less than or r cannot be negative anyway. So it is the shaded part. Where is theta, ya jamaa? Theta is free. Theta is from 0 to 2 pi. All the cycles. Theta is no condition or theta here. So we move all the cycle from theta equals 0 up to theta equal pi. Phi from 0 up to pi over 3. R, rho, sorry. We have to distinguish between rho and r. Here in spherical, it's rho from 0 up to 2. These are the bounds. If we integrate, or we need to find the volume of this ice cream cone, we have to integrate over this region. This bounds for rho, these bounds for phi, these bounds for theta. Any question? This is the typical example we get in a question of triple integral using spherical coordinates, using cones, spheres, cylinders, and this stuff. We need to be familiar with this. Any question? Shahab?
كله تمام.
Katrina?
أنا
Sama?
تمام يا دكتور.
تمام يا دكتور.
تمام. Okay. The final piece we need to be familiar with before doing the triple integral using spherical coordinates. We are used to the transformation. We are used to the sketching. The last part is the dV, the volume element in spherical coordinates. We know by now that dV is dz, dy, dx, and can be written in 6 ways in rectangular. And here in cylindrical, we know as well, cylindrical, what happens? We change dx dy into, as you know, r dr d theta. dz is the same, but dx dy to be changed with r dr d theta in cylindrical or polar. You know all of that. R theta, cylindrical is r theta and z. dz is the same, r theta as in polar. Instead of dx dy, we put r dr d theta. Why is that? Because the change in r is dr, but the change in theta yields a change in the arc, which is r d theta. We explained this in details before. So now the situation is much more complicated in spherical coordinate system, because the element of volume here will be rho square sine phi d rho d theta d phi. Why is that? I leave this for you to study. It's easy. It's not much. It's nearly the same. Same explanation we have had before in polar coordinates and cylindrical coordinates. When we have a change in theta, delta theta, the corresponding change in the arc will be r delta theta. But what is r? R is rho sine phi. So it's rho sine phi delta theta. The other change in the angle phi will produce a change in the arc here, rho d delta phi. And the change in r rho is delta rho. Multiplying all of this stuff, we get delta v. This is magnified element. This is dv, delta v. In the limit will be dv. Multiplying all of these sides, sp times pr times pq, we get the volume of this element, which will be in the form rho square sine phi d rho d phi d theta. Instead of dx, dy, dz, instead of dz, r dr d theta in cylindrical, in spherical we have this complicated volume element. Rho square sine phi d rho d theta d phi, or d phi d theta, same story. Why is that? Because the change in the angle will produce a change in the arc, as we explained before. If you have any question after studying this, it may take some time to understand. Its sketch as well is not easy. Needs some time to handle and digest it and convince yourself with it. But we will use it as a formula. We can use it directly without explanation. The element of volume dv in spherical coordinates is rho square sine phi d rho d phi d theta, or d theta d phi. That's it. So in summary, what we will have, spherical coordinates are especially useful with cones and spheres. For example, if we have this cone, z equals root 3x squared plus y squared, so this will be phi equals some angle. Z equals, how to transform this into x and y. We studied this. We had many examples already. So what we do is Shihab, take 3 common factor. X squared plus y squared is r squared. This will give you z equals root 3. So z over r, which is tan phi, is root 3. So phi is pi over 6. This is the half cone again, Catherine. If we have phi equals pi over 2, we have another half cone, and so on. Then the typical example is root x squared plus y squared is phi equals pi over 4, because tan phi will be 1 here. Tan phi will be 1 here, because there is no this root 3. Okay, now is the time to have some triple integral example on the triple integrals using spherical coordinates. Any question before having this example? I'll send you more solved examples in details. Please study it by hand, and any questions send and or come to the office hours, inshallah. So now evaluate. We are in a position to evaluate triple integral in spherical. What postponed this was to wait until we know this element of volume. This is the most difficult formula we have in our course. The difficulty is with its derivation. but its use is nothing. This is direct. So now let's evaluate this triple integral of this integrand. This is a function z, function of xy, or f of x, y, z is this function. May represent what? May represent density, electric charge density, whatever. dv. So it's a triple integral over some region. The region will be explained to you. Solid, E is solid below this equation and above the xy plane. So we need to tell what is this equation. Who can tell? Shihab?
ممكن حضرتك تفهم السؤال تاني يا دكتور؟
Yes.
دي هتبقى دي equation of اللي هي P دي.
This what?
Yeah,
X
P
square
equals
plus y square plus z square equals 1.
the equation of the sphere.
Sphere, yes. Sphere with radius 1, center 0, 0, 0. The center is the origin and the radius is 1. But solid below, the solid below this sphere and above the xy plane. Above the xy plane, so he speaks about not the whole sphere, it's half sphere. The sphere, the solid below this sphere and above the xy plane. So what is the region, Sama?
يعني above ال XY plane كله
Yes.
بقى من 0 to 1 يعني half.
Yeah. Above the xy plane and below the sphere. يبقى half sphere. It is the upper half sphere, hemisphere. Okay? What is below the sphere and above the xy plane? And the sphere is symmetric about the xy plane, about all the axes, about the origin. Half of this sphere is above the xy plane and half of it is below the xy plane. He speaks about the portion of the sphere above the xy plane. Got it, يا جماعة?
Oh, yes.
تمام.
Yes, Katrina? تمام.
تمام.
So can you make it easier? So now you will be asked to put it in spherical or leave it with you. Maybe you decide to transform it into spherical or whatever. If we transform it in spherical, what will happen? This will be very easy. Why? Because all of this will be rho equals 1. The equation will be rho equals 1. Okay. So who can help in finding the bounds of the integration? How to describe this solid? The bounds for rho, the bounds for theta, the bounds for phi.
احنا عارفين ال phi هتبقى من 0 ل 1.
Phi. Phi is the angle. Phi is the angle, Shahab. So let's go slowly, Shahab. Let's go systematically as we are used to, Katrina. We go fix theta and phi and go from inside up to the surface. Fix theta and phi and go from the smallest row.
كان قصدي rho من 0 ل 1.
Okay, rho, yes. Rho is from 0 to 1 to meet this. Yes, to meet this sphere. From rho from 0 to 1. Then how to scan all of the region using this spherical strip. I mean how to move phi, how to scan for phi and theta to cover all of the region inside this hemisphere.
Theta هتبقى الcircle كلها from 0 to 2
Yes, theta goes this way. This is theta from 0 up to here. Theta equals 2 pi, the whole cycle. And phi from 0 up to the xy plane, phi equals pi over 2. phi is 0 here يا جماعة. Phi here on the z axis we measure phi from the z axis. Here is phi is 0. When you move this way, this is phi equal 30 degrees, pi over 6, pi over 4, pi over 2, and so on. Here on the xy plane, phi becomes pi over 2. If you go down, phi becomes bigger than pi over 2 and less than pi. If you go down the z-axis, the negative z-axis, phi will be pi. And this is the end of phi. We don't need any more phi, because you have already the other side with the same angles. Again, if phi is pi over 3 here, this is a cone. So we have all directions. Okay. So this is the bounds for theta and phi and rho. So let us change to go to spherical coordinate system. The bounds will be, and we change x square plus y square into r square, and dv, you know, r is r rho sine phi, and dv is this long volume element rho square sine phi d rho d theta d phi, or d phi d theta is the same. So substitute for x square plus y square as r square, and then r is rho sine phi whole square. Therefore, we have rho sine phi compound square times dv is all of this stuff, rho square sine phi d rho d theta d phi. And these are the bounds for rho from 0 to 1, fixing theta and phi. Then move phi from 0 to pi over 2 till the xy plane, and at the end theta moves the whole cycle from 0 to 2 pi. Now we have the situation where we can simplify and do it as product of three integrals, because we have what? We have made this in the 7 sections before. When we have separable functions, the variables are not implicitly made in a complicated relation. We have separable functions here. Rhos and phi's and d thetas can be separated. And the bounds here are constants. Look here, these constant bounds for rho, constant bounds for phi, constant bounds for theta. So therefore, we can find I by multiplying three integrals: an integral for rho, an integral for rho phi, an integral for theta. So we get this stuff. And to finish the integral, this is easy. You can do this alone. This is without thinking for a minute. This is theta from 0 to pi, we get 2 pi. Rho power 4 gives you rho power 5 over 5 from 0 to 1. This needs some work. This is sine phi. And here the sine square will be made 1 minus cosine square phi d phi. And this is from 0 to pi over 2. This needs some technique of integration. This is the technique. Because we have sine cube, we made it sine times sine square. And sine square is 1 minus cosine square. What do we do? Why do we make this transformation? Because this u substitution. We can make u substitution as u equals cosine phi will give you this is the derivative of cosine phi, but with some change of sign, because du will be negative sine phi d phi. So this is 2 pi, this is 1/5, and here 1 to the 5 minus 0, which is 1. Here again, one minus cosine phi square. Here we need negative sign. Sine phi d phi, which is du. This is u, this is du. So it's minus 2 pi over 5. What is the integral, Shahab?
اللي هي
To make
بتاعت
the substitution, the substitution is u is cosine phi. So 1
1 minus u,
y 1 minus u, yes. We
1
need
minus
to,
u squared.
yes. What is the integral of 1 minus u squared du? It's u.
Yes. لا. Oh, I.
Cosine phi cube over 3. U is?
Cosine phi.
Yes. So 1 du is, it gives u. What is u is cosine phi. And here is phi from 0 up to pi over 2. You need to work these examples yourself and be familiar with this sort of transformations and complete your integral techniques. Here, cosine pi over 2 is 0. Cosine pi over 2 is 0, so we get 0. Minus phi cosine 0 is 1, minus 1 over 3. So minus 2 pi over 5. Here we get negative value, negative 2/3. The final answer is 4 pi over 15 as promised. Yes, this is right answer. If you need to make this substitution in more details, do it. Don't worry about it, but you need to practice this a lot.